everyone. So today we are going to do a very interesting topic in economics. That is the concept of a linear function. Now, why are linear functions important in economics? Okay. Now the term linear may sound very technical, but उसका बहुत simple सा मतलब होता है. उसका ये मतलब होता है कि अगर आप एक वेरिएबल को एक यूनिट से चेंज करेंगे, तो दूसरा वेरिएबल एक फिक्स्ड क्वांटिटी से चेंज होगा. ठीक है. Now in our daily life, we can see that, for example, if price of a commodity decreases, the demand will increase. That is what happens. Okay, so you can see that one thing is decreasing, the other is increasing. For example, if you look at the usage of CNG vehicles in our country, so you know that the price of CNG is very less compared to the price of diesel and petrol. So with the decrease in the price of particular type of fuel, the demand of that kind of motor vehicle increases, which is using that fuel. So that is why we study relationships between variables. And the first most important relationship is the linear relationship. Okay. And that is why we study functions. So we have different kind of functions. The first kind of relationship that is very important in economics is linear function. Okay. So what is a linear function? A linear function is something where when you have change in one particular variable by 1 unit, you will see or you will measure what is the change in another variable which is depending on it. All right. So let us understand it through a question. And please let me know in the comment box whether you understand it or not. Okay. So what do you mean by a linear function? First of all, we will be discussing. Okay. So let me give you an idea about it. So basically, in a linear function, if y is a function of x, okay, if y is a function of x, so y is of this particular form, ax plus b, okay, so where a and b are constants, okay, and x is the independent variable and y is the dependent variable. Okay, so basically what are we exactly trying to say is that if x changes by 1 unit, by how many units y will change? So let us try to know it through an example. So for example, let us take x to be 1, the initial point, the initial reference point, then y will be equal to a plus b. Then change x by 1 unit. That means let x be 2 now. Then your y will be 2a plus b. So if you notice the difference is y, so this is y1 and this is y2. So the difference in y will be 2a plus b minus a minus b. So that will be a. Okay. Similarly, if you now choose x to be 3, so from 2 to 3, again the difference is 1. So y3 will be 3a plus b, and y3 minus y2, you will again notice that it is again going to be a. So with 1 unit change in x, there is a units change in y. So basically with every unit change in x, the change in y is a constant, and that constant is a over here. And such kind of functions are called linear function. The basic definition of linear function is this. All right. So basically this quantity a is called the slope or the gradient of the function. All right. So now let us look at this particular example. I will do it by the basic definition. Okay. A firm finds out that 30,000 units are sold when the price is rupees 15, and 20,000 units are sold when the price is 20 per unit. Okay. So basically the quantity is 30,000 when price is 15 per unit. Okay. And the quantity sold is 20,000 when the price is 20 per unit. So you can notice that when the price has increased, the quantity demanded has decreased. All right. Now, assuming the relationship between the quantity demanded and price to be linear, find the quantity demanded at rupees 30. Now, they're telling you that assume the relationship between the quantity demanded and the price to be linear. So, Q depends on P. First of all, Q depends on P. All right. So let price, let number of units be X. Okay. So number, or in fact, let's not do it in terms of number of units. Q depends on P. So Q is expressed in terms of P. So Q will be equal to AP plus D, because Q and P are linearly related. Okay, they are linearly related to each other. So A and B are constants which we will be determining. All right. So now first you put Q to be 30,000 and P to be 15. Then you put Q to be 20,000 and P to be 20. So both these equations should be satisfied simultaneously. And now you subtract the second equation from the first equation. All right. So what you will get? You will get 10,000 is equal to minus 5A. All right. So A will be equal to 10,000 divided by minus 5. So A will be equal to minus 2,000. First of all, you got the value of A. Now put the value of A in any one of these equations. Let me put this in the first equation. So 30,000 is equal to 15A minus 2,000A, 2,000 into 15 plus B. So 30,000 equals to, so A is coming to be minus 2,000. So it is minus 2,000 plus 15 is minus 30,000 plus B. So B is coming out to be 60,000. All right. So your equation now becomes Q equals to AP plus B. So where Q will be equals to minus 2,000, B plus 60,000. This is your equation. All right. So you can test this. If you put P to be 15, so your Q will be minus 30,000 plus 60,000, which is 30,000. If you put P to be 20, which is going to be, Q is going to be minus 40,000 plus 60,000, that is 20,000. That means our equation is correct. So now I have got a linear relationship between the quantity demanded and the price per unit of the object that is being produced in the industry. All right. Now I want to find out the quantity demanded at rupees 30. So now I know the price is 30. So basically I really want to know that what happens if my price is increased to 30. Obviously I want to make profit. So how will I come to know that, what will be the demand if I increase the price to this? Will there ever be a demand or not? Will people stop buying or continue buying at the same pace or not? So let's see. So quantity demanded will be minus 2,000 into 30 plus 60,000. Okay. So you can see that the quantity demanded will be 0. So in fact, 0 amount of products will be demanded at price 30. So I cannot raise my price to be 30. So please comment in the chat box whether you understand this or not. And this is one very nice example of using a linear equation in our daily life to understand what should I keep the price to be, so that people keep on demanding the product. I should not be, pricing my items so high that the demand stops. So provided the relationship is linear. Okay, so this is one very nice example of a linear function in economics. And please keep on watching us for more such information videos. Thank you very much.